Okay, so in the first exercise we are asked to write a short Python function called isMultiple, which will take two integer values n and m, and will return true if n is a multiple of m. Okay, perfect. So to do that, we're going to use the modulo operator in Python. First, let's define the function. So n, and I'm going to also use type hints. N is going to be an integer and also m an integer, and we want to return a boolean. Okay, so we want to check if n is multiple of m. To do that, we can use the modulo operator, which is the percentage sign. What this operation will return is the remainder after dividing n by m, and if the remainder is 0, that would mean that n is a multiple of m. So pretty easily we can say return remainder equals 0. Okay, so that should actually do it, and to test it I'm going to run the script. Going to chapter 01, so I'm going to run the script interactively using the, python-e and the name of the script, and I can call isMultiple. We can try with something that we know is false for 3. Okay, so this is false, and if we do for 2 is true, and 10 to. Okay, so this works, and it's a pretty short solution, but we can actually turn this even into a one-liner. We don't need to perform this check. We can because in Python you can when you convert a value into a boolean, 0 will be false. So we can use that to make our code even shorter. So we can actually do something like this. First I'm going to exit. So instead of returning here, I would do something like return not. So if n modulo m is 0, which evaluates to false, but for us it in this is the case where the function should return true, because in fact, well, n modulo m will be 0, which evaluates to false, but for our case, that is the case where true should be returned by the isMultiple function, which would mean that n is a multiple of m. That's why I'm using the negation here with not. So we can try it again, and isMultiple for 2 is true, and if we do 5, 2 is false. Yep, I think that's it for the first exercise. Make sure to subscribe, because I will solve all the exercises in the data structures and algorithms in Python book. See you in the next one. Okay, so let's continue with the second problem. We need to write a short Python function isEven that will take an integer value and return true if it is even and false otherwise. But the trick is that we shouldn't use any multiplication, modulo, or division operators. Okay, so the easiest way to do this without using any of the above mentioned is to use to convert the integer into the binary form. So convert it into a base 2 number, which is written only in zeros and 1. Luckily in Python that is pretty easy with a built-in function called bin. So I am going to first create a function, and it's going to take an integer and needs to return a boolean. Okay, so first I'm going to convert that integer into the binary form. I'm going to define it as b, and it's going to be just bin and k. I am going to print that just so you all can see what bin returns. Let me run this interactively. Oops, Python 3. Okay, so if I do is even 4, yeah, this is 100, and these are before that, these are all zeros. That's why, and the B here is to truncate the string. So this is a string with zeros and ones, and this is the binary representation of the number 4. To check if a number is even, we only need to check the last bit. So if it's a 0, like in this case, it should be an even number. So I am just going to access the, I'm going to exit. I am going to access the last bit by just doing, since it is a string, I can access the last a character in the string by using -1, and I basically just need to check that this one is equal to 0. So if this one is equal to 0, then we have an even number, and it will return true, a boolean. If it's 1, then it should be false. So let's try that again. So is even, and I can try with 6. Oh, we've got something going wrong here. We need to check. So I am accessing the last number, and I am checking if it is, oh, actually, this should be a character 0, because this is a string and not an actual integer. So I think that was the issue. Let's run it again. Okay, so is even 6 is true, 7 is false. Let's try one more for good measure. Is even 8 is true. So yeah, just keep in mind that here this one returns a string and not an integer. That's why we got that error before. Okay, so that's it for this video. Yep, see you in the next exercise. So in the third exercise, we need to write a short function min-max, which will take a sequence of one or more numbers and return the smallest and the largest number. Okay, but we cannot use the built-in functions min or max. Okay, let's get started with this one. Find the function, and I'm going to use the type hints. So this is going to be a list of integers, and it should return a tuple to integers. Now, the way we're going to do this is we're going to declare two variables to store the minimum value and the maximum one. And we're going to initialize those two values with the same value, which will be the first element in the list. Okay, so I'm going to have min val is going to be data 0, because we know that the input is going to be a list with at least one element. And max val is going to be data 0 again. And now the simplest solution is to just iterate through the list. So I'm going to iterate through data and check if x is smaller than min val. I'm going to make min val equal to x. Okay, so and the other condition is going to be if x is bigger than max val, then max val is going to be equal to x. And in the end, we just need to return a tuple with min val and max val. Okay, let's try this out. I'm going to run this interactively as always. So if I just give a list with one element, it's just going to give me both min and max as 5. If I do 4, 1, 23, 7, 12, and 5. Let's see. Okay, so we get 1 and 23, which let's put some negative numbers. -7, 1, and then -2. Okay, it gives -7, 23, which are the correct ones. So that was it. That's the solution for this problem. See you in the next one. Okay, so in the fourth exercise, we need to write a Python function that takes a positive integer n and returns the sum of the squares of all the positive numbers smaller than n. That should be fairly easy. We define the function sum square, and it will be an integer, and in the end we return an integer again. Okay, so now the easiest way to do this is by looping through all the integers up to n. But first we declare a variable s, which is going to be equal to 0, where we will store the sum of all the numbers that we iterate through. And now I'm going to use the range built-in function in Python. In this case, range is going to produce a list of numbers starting from 0 up to n minus 1. So it will not include n, and this is what we need in this case. To do that, I'm just going to do s is equal to s plus x squared, and I am going to use the shorthand notation. Okay, and in the end, we can just return s. Let's run this. Okay, some squares, and if I do 5, I get 30, which I guess is right. 1 squared is 1, plus 4 is 5, plus 9 is 14, and 4 squared is 16, 30, so sounds right. Okay, that was really easy to do using a loop, but in the next exercise, we are asked to do the same thing, but just using a one-liner, and we can use the built-in sum function and the list comprehension syntax in Python. So let's rewrite this function. I'm going to stop running the script. I'm just calling this sum squares 2. Okay, so this is going to be first, let's make the list of all the squares small of the numbers smaller than n. And to do that, we can write a comprehension like this one, which is going to be x squared for x in range of n. Okay, so this is a list comprehension that will produce the list of squares that we need to sum. And we can just use the sum function, the built-in sum function, to sum it all up, and we just return it. Okay, so we can run it again and do sum squares 2. And if we give it 5, it's going to produce 30 again. Okay, so that was also the fifth exercise, rewriting of the sum of squares. That's it for this video. I'll see you in the next exercise. So in exercise 6, we're going to write a Python function which will take a positive integer n and return the sum of the squares of all the odd positive integers smaller than n. So I'm going to call this sum square odds, and it's going to take an integer and it's going to return an integer again. the same as with the previous exercise, we're just going to declare a sum equal to 0, and we're going to iterate in the range of n. So this will not include n, which is what we want because it says smaller than n. And now we have to check if x is an odd number. And to do that, we're going to use the modulo operator. So we're going to do, so if x, oops, mistyped there, 2, so x modulo 2 will actually give us 0 or 1. If it's 0, it means it's an even number, so we want it to be 1. And we can actually leave it like this because 1 is evaluated into a boolean true and 0 false. So in this case, we want the x modulo 2 to return 1, which will be evaluated to true. And that would mean that x is an odd number. Then we just add it to the sum. That's to the shorthand notation, x squared. And in the end, we just return s. Okay, and let's run this interactively, like always. Let's try sum square odds, and let's try 5. Actually, this returns 10, which is right, because the odd numbers smaller than 5 are 1 and 3. 3 squared is 9. 1 plus 9 is 10. Okay, so that was the solution to 1.6. But 1.7, again, asks us to rewrite this into a one-liner. Again, we're going to use the list comprehension syntax. And I'm just going to call this, let's copy this part and just call it 2. And what we're going to do is, first let's create the list comprehension. This is going to be x for x in. So we are going to iterate again in the range of n. Oh, sorry, we want x squared. And in here we can perform a check if x %2, the same that we did in the previous exercise. So this will give us a list of the squares of odd numbers smaller than n, and we can just perform the sum and return it. Let's run it again. If I do sum square odds 2 and give it a 5, I have to, yeah, it returns 10. Yeah, that's it for these two exercises. See you in the next one. Bye-bye. So in the 8th exercise, well, Python allows negative integers to be used as indices into a sequence, such as a string. And if a string s has length n, and expression sk is used for index k, which is between minus n and 0, which means it's a negative number, we need to find the equivalent index j, which is a positive index, such that sj references the same element as sk. Okay, so let's try to do that on an interactive shell. I'm going to run Python 3 here. So let's say we have s, which is a string abcd. Well, let's add some more letters. And let's say we have k, which is equal to -2. And if we try to access sk, we get e, because we start counting backwards. -1 is f and -2 is e. Now, we need to figure out a way how we can, how we can find the positive index. So, but first let's calculate the length of the string n, which is going to be n of s, and n is 6. So if k is -2, we can actually try to infer it by just counting. In this case, it's the easiest way. We see that e is the 5th letter in the string, which means index 4, because we start counting from 0. So in this case, j is equal to 4. So we can say that sj is equal to e. So we can derive a pattern from this one, which is that in this case, j is equal to n plus k. You see, j is 4. So we can actually answer the question in the exercise and say that j needs to be equal to n plus k. Okay, so I'll put that also on the GitHub repository. So that was the answer to the 8th question. We figured out a way to calculate j using n and k. And the next exercise, first let me stop this. Okay, and I'm going to comment this one. In the next exercise, we need to find what parameters should be sent to the range constructor to produce a range with values 50, 60, 70, 80. Okay, so for that I'm going to use the interactive shell. And this is actually pretty easy to use the range function. Well, actually to print the sequence, we need to convert that range into a list. So that's why I'm going to do a list, and inside the list function I'm going to call range. And first I'm going to give the value where we're going to start, 50, and then I need to give the other boundary, but it needs to be a number bigger than 80, because if we put 80, then it will not go to 80, because 80 is not the second number is never included in the range. So I just have to go larger than 80, so I'm just going to put 81, and we can see that the numbers are just increased by 10. So I'm going to give a third argument, which is going to be 10, the step, and let's see. Yes, and this gives the thing we actually want. So I'm going to put this right here, and I'm going to put it inside a print. Perfect. And the next exercise, again using the range constructor, we need to produce another range of values, but in this case we're going backwards. We are starting from 8, 6, 4, 2. Again, we can do this pretty easily. List range, I'm going to start from 8. I'm going to put as the second argument a number smaller than -8, so -9. And as a step, I'm going to put -2, because we see we always decrease by 2. And that's what we need in this case. Let's put it here. Okay, so that was exercise number 10. And for number 11, we need to use the list comprehension to produce this list. You can see that all of the numbers in the list are powers of 2. I think up to 2 to the power of 8. So I'm going to use the list comprehension for that. It's going to be something like this. 2 to the power of x for x in range 9. Okay, let's close it, and that's it. We can actually put it here. Okay, so those are the 3 exercises we're going to solve in this video. I'm going to catch you in the next one. In this exercise, we need to write another function that will take a sequence of integer values and determine if there is a distinct pair of numbers. Okay, let's start with that. I'm going to call this function find odd pair. Well, the thinking is that if a pair of numbers have the product to be odd, then both of those numbers need to be odd numbers. So if we find that in the sequence there are 2 odd numbers, then we basically solved it. So that's what I'm trying to do. It's going to take a list of integers as input, and in the end we just need to return a boolean. Okay, so the easiest solution I can think of is to first convert the list into a set, because a set in Python will only contain distinctive numbers, and after that we can go through the set and then just filter out the numbers that are odd. So we can do that with a set expression actually in a one-liner. I'm going to call this odds, and it's going to be x for x in data if x percentage 2 x modulo 2. This will return 1 for an odd number, which will evaluate to true. So now we will have a set of numbers that are distinct and that are odd. So we just need to check if the length is larger than or equal to 2. Okay, so we can test that here in the interactive shell. Oops, mistyped there. Yeah, these are from the previous exercises. We can ignore that. I can try to call the function find odd pair, and oh, we've got actually an error, and yeah, the type object is not subscriptable. Let me stop it here and just, yeah, we can just use the list from the type hints, but I need to import it. Yeah, we already have it there. Yeah, so we can rerun it. Okay, so find odd pair, and I'm just going to give a list of numbers for 1, 2, and in this case we only have one odd number, so it should return false, and it does. But if I add 3, I can actually make this another odd number. This should return true because 7 and 3 are 2 odd numbers, and it does. So that was it for the first exercise. In the next one, we need to write another function that takes a sequence of numbers and just determines if the numbers are all distinct, which means different from each other. Okay, so I'm going to call this check distinct. Again, this is going to be a list, integers, and it will return boolean. There's again a very easy solution to this one. We can just check if first we can convert the data into a set and check if the length of that set is equal to the length of the original list. Okay, and the reason we're doing that again is because a Python set will only contain distinct numbers. Okay, so we can try and test that. I'm going to check distinct, and I'm going to give a list of numbers which is actually distinct, and it returns true. But if I repeat, for example, 2 here, I will get false. Yep, that's it for this exercise. See you in the next one. In this exercise, we need to find a list. We need to define a list comprehension to produce this list of numbers. Okay, so the hardest part here is to find a pattern. The first thing we notice is that this is a list of numbers with 10 elements, so we need to produce something with 10 elements. I'm going to run the shell here, and first I'm going to produce a list of numbers, which is going to be it's going to be a range of numbers from 1 to 10, but I'm writing 11 as the end of the range because 11 won't be included. Okay, so first idea I have is to square the numbers, because you can see how they get progressively bigger as we go from 1 to 10. So we can try this, a list comprehension where x squared or x in range 111, and we get these numbers. Now I am just going to try and find a pattern here. If you notice, 190, the difference is 10, and 81 and 72, the difference is 9, 64 and 56, the difference is 8, which is the basically the number x. So we can write something like this: x squared minus the number x, and this should produce, yeah, exactly the list that we want. So in the end, this is the list comprehension. In this exercise, we need to use the list comprehension to produce the list of all the letters in the alphabet, lowercase, from A to Z. But the catch is that we shouldn't type all characters. So one way to do this is to use the Unicode for every character. And Python has some built-in functions to deal with this. One is ORD, and the inverse is CHR. I don't know how to pronounce it, but I'm just going to say CHR in this case. So first, ORD. With help, we can see the Python documentation. We see that ORD will return the Unicode code point for the one character string. So ORD A would give us 97, and if we do ORD B, 98, and you see that all the Unicode code points are sequential from A to Z. So if we do ORD Z, we get 122, and the inverse of ORD is CHR, and if we try 97, it will give us A, and 122 will give us Z. So we can write an list comprehension by doing, we can write CHR X for X in range, and we will start from 97 up to 123, because 123 won't be included. So we get the whole alphabet. So this is the list comprehension we need for this exercise. In this exercise, we need to imitate the function shuffle that is already provided by the Python random module to randomly reorder the elements so that each possible order occurs with equal probability in a list. For that, we're going to use a more basic function called randint that returns a uniformly random integer from A to B, including A and B. So first, let's see on the terminal what shuffle already does. So I'm going to run Python 3, and I'm going to import random. So if we have a list of numbers, A is going to be list using range 9. So it's from 0 to 8. And if I do random dot shuffle A and then print A, now we see the list of numbers reordered. Okay, and randint does so that if we give it a start and a stop, so from 1 to 8 is going to give us a random number between 1 to 8, including 1 and 8. Yeah, I'm trying to run this again. Type. Okay, and that's quite random. Yeah, let's stop the shell, and I'm going to write the function right here. I'm going to define this as my shuffle, and it's going to take data, which is a list, and it's going to return a list. Okay, so what I'm going to do in this case, I am going to go through all the elements in the data list and then try to do a random swap. So let me write some code, it will make it much clearer. First, I'm going to get the length of data. This will make it easier. And I'm going to iterate through I until range of n. So this will be iterating through all the indexes in the data list. What I'm going to do then, I am going to get a random number between between I and n minus 1. So what this will do, so if we think of it this way, and I need to import random first. From random import. So what this will do, we'll try to get a random number starting from current index up until the last one. So when we are in our first iteration at I0, we're going to get a random number between 1 and n minus 1. So we want to swap the first element in this case with a random one, and we're going to do that for all the elements in the list. In this case, we will get a random reordering of the list. So after we get that random index, what I want to do, I want to swap the element at index I with the element at index j, and I'm going to do it like this. Python is really nice to do this swap here. Data j, data I. Okay, and this will actually perform the swap and do it on every iteration. And in the end, I just need to return data. And let's see if this works. So I'm going to run it interactively. Oh, discard these are from the previous exercises. So I'm going to do A is equal to list range 9. So A is a list of numbers from 0 to 8. And if I do my shuffle and I give A as input, it will give me a random reordering, which is like the provided function shuffle does. So yeah, that's it for this exercise. Okay, so in this exercise, we need to write a program that will repeatedly read lines from the standard input until end of file error is raised, and then output those lines in reverse order. And of course, we can end the input by typing Control D. Okay, let's get started. For that, I'm going to create a function main. and then I am going to first write something to get repeatedly input from the user. I'm going to use an infinite loop by doing while true intentionally, and I am going to get the input, a line input, which is I'm going to store it in a variable L, and it's going to be an input. I'm just going to show this is a prompt, making a space here. I am going to get that input and I'm going to store it in list. So I'm going to declare here input lines. It's going to be a list. So input lines dot append. I'm going to store it there. Now, to break this loop, we need to enter Control D. So I'm going to do some exception handling here. I'm going to put this into a try block, and then except for EOF error. And if we get an exception, what we want to do is we want to break the loop. After breaking the loop, we need to show all of the input lines, but in reverse order. And to do that, I am going to make for loop for L in reverse. This is going to reverse the input lines. I'm just going to print it. So I'm going to print the line. Okay, let's try this out. And to run it, I need to use this Python equals to main, and this would make us run. Okay, let's run the script, and I'm going to do, okay, so I get a prompt. I'm going to type first line, second line, third line, and I'm going to stop it with Control D. And this is what's happening. It's printing the lines, but in reversed order. So that is exactly what we need. I just don't like showing this in the same line with the prompt, so I'm just going to do a print here to print a new line, \n. Just a small improvement. And yeah, so let's run it again. First line, second line, third line, and fourth line. And I'm going to type Control D, and I get fourth line, third line, second line, and first line in reverse order. Okay, so that's it for this one. See you in the next one.
In this exercise, we need to write a program that takes two arrays, A and B, of length n, storing integer values, and return the dot product of A and B. So the dot product is going to be a new array C of length n, such that each element of C is the product of the corresponding element in A and B. Okay, let's do that. I'm going to define a function dot product, which is going to take two arrays that are going to be list of ints, list int, and B is going to be list of int, and it's going to return again list of ints. And I need to import the type list. I'm going to do that right here from typing import list. Okay, so what I'm going to do first, I'm going to declare a new array C, and I'm going to iterate through, well, in this case, we need to iterate through the range, or I in, well, we have to go through the indexes of each list. And the range is going to be the length of A. It could also be the length of B, since the length should be the same for this to work. And I'm going to append to C the product of AI with BI to produce the new array. And in the end, I'm just going to do return C. Okay, let's run this, see if this works. And I'm going to do Python 3 interactively. Okay, let's run .product, and the first array is going to be 1, 2, 3, and the second one is going to be 4, 5, 6. And we get, 4, 10, 18. Yeah, that's it for this one. Okay, in this one, we need to give an example of a Python code fragment that attempts to write an element to a list based on an index that may be out of bounds. If it is out of bounds, we just catch the exception and print a message, which is don't try buffer overflow attacks in Python. Okay, I'm going to put this in a function, so I'm going to define it, write to file, to list, sorry, and it's going to take a list and then an index, which is going to be an integer, and the value that it will write to. It will return a list again. Okay, so what I'm going to do is I'm going to create a try except block. So first I'm going to try and then try to set the value at the index. And we can do that like this. And try to catch the index error. If we have an index error, we need to print this message. Just copy this. Oh. Yeah, just ignore the output. And if we catch the error, we just print there is something I need to copy it properly. So Control C. Okay, so we need to print that, and if everything works fine, we just return the new array. Or return A. We can try this by running the script interactively, as always. So I'm going to open the terminal again. And I'm going to do Python 3. Run the correct script. And I'm trying write to list, and I'm going to give an array 1, 2, if I could type, 2, 3. I'm going to give an index that is out of bounds, let's say 11, and I want to give it the value 55. It will print the message, don't try buffer overflow attacks in Python. But if I do index 2, then I get I write to the list, I override the element at index 2. That's it for this exercise. Okay, in this exercise we need to write a function that counts the number of vowels in a given character string. And all the vowels are here, are A, E, I, O, U. I'm going to write a function, oops, not in all caps, count vowels, and it's going to take a string, and it will return an integer. Okay, what I'm going to do is first create a counter, going to be 0, and then the easiest way to do this is just iterate through all the characters in a string, which we can do like this using a for loop, and then check if character is in the vowels string right here. and we don't need this anymore. If it is, we just do counter plus equals 1, which is the shorthand notation to increment by 1. Okay, and then just return counter. And that should do it. Let's try to run it proactively, and this is okay. Let's try to count vowels, and I'm just going to give a string sentence, and it gives us 6, and you can actually count them. 1 is here, I again 2, 3, 4 here, 5 and 6. That's it for this exercise. In this one, we need to write a short function that takes a string s representing a sentence and return a copy of the string with all the punctuation removed. So we don't lose any time. I've put here a list of all the punctuation marks in the English language. And what I'm going to do, I'm going to declare a function, remove punctuation, and it's going to take a string and it will return a string. I'm going to put this inside the function. Okay, and what I'm going to do next is declare a new empty string. It's going to be empty, and then I'm going to iterate through the given string and check if the character is not in marks. Then I'm going to append it to the new string. Oh, new str. Okay, and in the end, I'm just going to return the new str. That's easy enough. Let's test it. I'm going to do python-i. Okay, and if I do remove punctuation and I just give a string, this is an example. Oh, I forgot that my mistake. The string doesn't, I was thinking of a list, so instead of append, I just do this, use the plus notation. Yep. So this one should add the character at the end of the string. So let's try it again. I'm going to do this, copy and run it here. And it removes all punctuation. So that's it for this exercise. In this one, we need to write a program that takes as input 3 integers a, b, c from the console and determine if they can be used in a correct arithmetic formula, which are given here in order. Okay, to do that, first I'm going to write a function, check arithmetic, and it's going to take a as an integer, b again an integer, and c an integer. Okay, and let's think about what it's going to return while we write the function. First, I'm going to check if this condition is fulfilled, but we need to write equal c. And if it is, then we can just return some statement that these numbers can be used for this operation. Okay, so I'm going to do, or better, since the numbers can be used for multiple operations, let's store a results list, which is going to have
a list of strings with all what we want to print. And here I'm going to do results.append, and I'm going to put in a string, an F string, because I'm going to put A, B, C can be used in the operation and okay. This is the first thing we need to return. Now we're going to check all other operations. For this one, I have to check if A is equal to B minus C. And here I need to write. Okay, and the other one is going to be if A times B is equal to C. Okay. And in the end, I need to return a list of strings, or let's make it list type hint. So from typing import list. And also we need to think about the case when none of these are fulfilled. So if not results, so if the list is empty because we haven't appended any of these strings, we need to append that, well, let's copy the numbers. And we can say cannot be used in any operation. And in the end, we simply return results. Now we need to run this as a script. It's a Python script, so I'm going to do if name equals to main. And in here, first I'm going to get an input for A. Enter number A. And I'm going to go to a new line. I'm going to do the same for B and for C. So instead of A here, we want B. And here we want C. Okay, and then we do results equal to check arithmetic, and we give A, B, and C. And we want for every result to print it. Okay, let's try to run this. This is 126. Let's enter 5, 4, and 20. Of course, because the inputs are all strings, so we need to convert them into integers. Let's do that here. Int B and int C. Okay, so now we converted them from strings into integers. 5, 4, 20, and yeah, that's it. We can also try it again with numbers that don't fulfill any. So 6, 6, 6 cannot be used in any operation. That's it for this exercise. In this exercise, we are going to look at the implementation of the generation function that computes factors of a given integer. So I copied this one from the textbook. This was the third implementation, which is the most efficient. And yeah, this one will yield us all the factors of a given integer n. Let's try to run it so we can see what it does. I am going to do it. I'm going to loop through the generator. I'm going to give it a value 8, and I'm going to print them. F in factors. And I'm going to run it. Okay, so it prints all the factors, but it does not print them in increasing order. So this is what we need to do while maintaining the performance. Okay, so the thing is that if we go through the code, here we are checking if n divided by k gives us a whole number. We yield that k, and then we yield the other factor, which is n divided by k. Now, this bigger factor, we shouldn't yield it right away, because we need to go through all the small factors first and then yield the bigger ones, or larger ones. What I'm going to do, I'm going to create an array where I'm going to buffer those factors in. So this is an empty array. So instead of yielding right here, what I'm going to do is, let's call it larger factors dot append, and I'm going to append this larger factor. Okay, so I'm appending, and then after I go through all the small factors, yield them, and yield the square root if there is one, then I'm going to go through the larger factors. I'm going to write a while loop, and I just need to check while larger factor. So if the array is not empty, the list is not empty, then I'm going to pop the last element from the list. I'm popping the last element because when I am appending, I'm always appending the smallest element at the end of the list. So I just start popping from the bottom, so that means that I will always get the smallest element. So I just do a larger yield larger factors dot pop. Okay, so let's run it again, and that's what we get. We get all the factors now in increasing order. That's it for this exercise. Okay, in the next one, we need to calculate the p-norm of a vector. So we will get a vector of integers and the power a power, and we need to calculate the p-norm. So let's define the function. It's going to be norm. Going to take v and p. V is going to be a list of integers, and p is going to be an integer, and it should return an integer. Okay, I'm going to import list. Okay, first what we need to do is we need to calculate the sum of all numbers in the vector, of all values in the vector, to the power of p. So first, let's create a list comprehension. This is going to be x to the power of p for x in v. Okay, and now we need to calculate the sum of this one, and the sum now needs to be, we need to calculate the root, the p root of that sum. And to do that, we can use the inverse of the power operation. So we're going to do to the power of 1 over p. Okay, and just return it, and this should actually do it. Let's try and run it. So if I do python-i 27, okay, let's try a simple one with the root of 2, which we know the result. So if I do norm, and I will give 3 and 4, and to the power of 2, and it gives us 5. But the 5 is a float and we want to return an integer, so I'm going to convert this one into an integer. Okay, let's run it again. Norm 3, 4, which is a list, and power of 2 should give us 5. That's it for this exercise. In this exercise, we need to write a program that will output all possible strings formed by using the character CAT and DOG exactly once. Okay, this is going to be a bit more complicated because we're going to use recursion for this one. First, I'm going to declare a function, get combinations. This is going to take all the letters, which is going to be a list of strings. And I'm going to import from typing list. And also, I'm going to have a list here, which is going to be called first as an empty list, where I'm going to store all the combinations I'm going to create. So this is important for the recursive step. And this is a list of strings as well. And in the end, what we want is to return all the combinations. And but we cannot actually return it we cannot initiate a list of strings inside the function and return it, because this is going to be a recursive function which will call itself. So we want to have a list, an empty list outside of the function, but that we modify inside the function whenever we call it recursively. It would make more sense when I write that code. So this function is actually going to return nothing, but it's going to modify a list of all combinations. I'm going to call it all combinations. It's going to be an empty list. And to modify it inside the function, I need to use the global keyword. So whenever we refer to all combinations inside this function, we refer to this global variable. Okay. If we're going to use recursion, we need to define the base case, which is if we provide an empty list of letters. So if this is 0, what we do is just append an empty string. Well, just append a string, which is going to be by joining the letters in the combination. If it's an empty combination, an empty list, then it's just going to be an empty string. Okay, that is the base step. And then on the else, what we're going to do, we're going to iterate through all the letters and take one. We take the letter at the ith position and put it on the combination, which is going to be empty in the beginning. So we do .append letters.pop I. Now, this is the important bit. We do the recursive step. We call the function itself, now with the letters and the new combination. So from letters, we have removed one element and put it into the combination. So this will allow us to run this recursively and get all possible combinations. After that, we do insert again .pop. So we take out the last element that we added on the combination and put it again on the letters list at the ith position. So it's ready for the next iteration. Okay, now what we need to do for this run, I'm going to first put this so that we run it as a script, and we can actually declare the all combinations in here, and or it doesn't even matter actually. We can leave it here and just now call get combinations. Let's try it with something simple like A, B, C. So put a list so it's easier to check. We know all the possible combinations of A, B, C. And as I said, we're going to call combination, we're going to initialize combination as an empty list first. Okay, we need an equals here. And now we need to print the all combinations. Let's run this. Okay, it's working. As you can see, these are all the combinations of letters A, B, C. And we can do the same for the required letters from the exercise. I'm going to put it as a string and then convert it into a list. Okay. As you can see, this is a huge list of combinations because those are 6 letters. That's it for this exercise. In this exercise, we need to write another program that will take a positive integer greater than 2 as input and write out the number of times one must repeatedly divide this number by 2 before getting a value less than 2. This is actually the concept of a logarithm in math. And there is actually a ready-to-use function in the Python math library, but we're not going to use that. We're trying to write it ourselves using recursion. So I'm going to define a function, find log, and it's going to take an integer. And we want to return the number of times, so we want to return an integer again. Okay, so we're going to use recursion, and as always, we need to write the base case first. The base case is going to be checking if the number is smaller than 2. So if we get a number smaller than 2, we need to return 0 because we cannot, so if 0 is the number of times we can divide this number by 2 and get something less than 2. So it makes sense for this to be the base case. And now for the recursive step, what we're going to do is we're going to call the function find log itself. So we're going to call this function recursively, but after dividing by 2, and we need to add 1. So adding 1 is actually increasing the number of times that we have divided by 2. Okay, so this will run recursively and give us the number of times. We can actually test this by doing a print here, find log, and let's write the, so we know the base is going to be 2, so I'm going to use a power of 2 so it's easier to check. Let's say it's 32, which is 2 to the power of 5. Let's run it. So I'm going to do, and we get 5. If we do 16, we get 4. And that's it for this exercise. Okay, in the next exercise, we need to write a program that can make change. So I guess this one will work a bit like a cash register. You should take 2 numbers as input. One is the monetary amount charged and the other is the money given. It should return the number of each kind of bill and coin to give back as change for the difference between the amount given and the amount charged. But we need to check and return the least amount of bills and coins possible. Okay, so for that I'm going to use the US currency, the dollar. So I'm going to first I'm going to copy. I already did this beforehand. I took all the currency units
in dollars and put them in an ordered dictionary. I did that ordered because I want to iterate through them, and I want them in order when I want to check the number of bills that I can return. So all the currency units here are starting from $100, $20, $10, but I have written them in cents to make it easier, since the list or the base unit is going to be the penny, which is 1 cent. Okay, so I'm going to use that, but I need to also import the order dict, which is from the collections library in Python. I'm going to do that here from collections, import order dict. And I'm going to create the function define make change. This one is going to take the amount given. So the first one, the first one should be the charged amount. So, and I'm going to not use the float or int, I'm going to use a decimal because it's more accurate and you avoid that floating point error. We can import that from decimal, import decimal. So the amount is going to be the charged amount is going to be a decimal, and the given amount again is going to be a decimal. In the end, we want to return a dictionary with a mapping of the bill name and the number of bills that we are going to return, or coin. This is going to be a dictionary with string and integer as a value. Okay, and I need to import this from typing. Import dict. Okay, great. Now I have I defined the function. I have the ordered dictionary of all the currency units. What I'm going to do is calculate the change, which is just going to be the difference between the given amount minus the charged. And I'm going to have that in cents, so I'm going to multiply by 100. Okay, so this is going to be in cents. Now I need in the end to return a dictionary with which I'm going to call change units. I'm going to declare it as an empty dictionary, and what I'm going to do now, I'm going to iterate through all the currency units, and I'm going to iterate through the keys and values because I need them both in currency units.items. This is the way you iterate through the dictionary in Python if you want to access the key and the value right away. Okay, now first I'm going to divide the change by the largest bill, so by the 100 bill in the first iteration. So what I'm going to do is, and I'm not going to use, you can also use the regular divide, but Python offers div mode, which gives you the quotient and the remainder at the same time, which makes it easier to write it in a one-liner. So I'm going to do, and it gives it as a tuple. So if you want to get the quotient and the remainder from the division operator, you get it as a tuple, and you can unpack it like this. So I'm going to do div mode, and I'm going to do change divided by v, which is the value in the currency units dictionary. Now, if there, it might be that the amount is smaller than 100 bills, so we have to check if actually there is a quotient in this case. If it is, then we need to add it to the change units, which is a dictionary, and is going to have k as a value, which is the name of the bill, and as a value is going to have the quotient. Okay, perfect. Now we check if there is a remainder. If there is not, so if not remainder, we actually are done, and we just need to return the change units. And if there is actually a remainder, we need to set the change to be the remainder. So we can continue dividing with a smaller bill, until we reach the last one, which is the penny. So we just iterate through it, and in the end, we just return the change units. Okay, so we can give it a shot. So let's try to make change, and I'm going to first I'm going to give the amount given. It's going to be a decimal. Let's give 35 or $30, and the amount charged is going to be a decimal, which is going to be, let's say, $12.99. Okay, let's run this, and I'm going to do Python. This is 30. Okay. Well, I think I put it the wrong way. We need to have this is the amount charged. Actually, the first one is the amount charged. So let me fix that real quick. Okay, let's do it again. So we get back a $10 bill, a $5 bill, which is so in the end we should get back, this is approximately 13, so we should get $17.01. So 10, 5, $2, two $1 bills, and 1 penny, which is exactly right. But I don't want to see the number of bills as a decimal, so I'm going to do something here. I'm going to convert it into an integer. Okay, so if I run it again, I get one $10 bill, one $5 bill, two $1 bills, and 1 penny. And that's it for this exercise. Now, in this next exercise, we need to write a Python program which is simulating a simple calculator. We will use the console as the exclusive input-output device. So each input will be a number or an operator, and that will be done in a separate line. And after each input, we should output to the Python console what would be displayed on the calculator. Okay, let's start writing some code right away. I'm going to define a calculator, or just calculate function. And what I'm going to do first, I'm going to read the first number from the console. So it's going to be A, and it's going to take an input, and then I'm going to say enter the first number. Leave some space here. And okay, next I want to get the operator. I'm going to call this op, and then input, enter one of the operations. So we're going to support plus, minus, multiplication, and division. Okay, so we need to enter one of these, and then enter the second number. It's going to be an input again. I'm going to copy and paste here. So enter the second number and make this first. What we want to do, we need to perform this operation on these numbers, and I'm going to define that as a separate function, perform operation, and it's going to take number A, number B, and the operation. And I'm going to define this as a float. I'm going to convert everything as a float. And then the operation is going to be just a string. Okay. And this one needs to return in the end float. Okay, what we're going to do here,
we're going to use some if cases to check, to go through all the operation options. So if operation is equals to a plus, we just return a plus b. Pretty easy. We do the same for all of those cases. So this is minus, and then we return a minus b. So let's do the same if it is a multiplication, and then the last one if it's division. Okay, perfect. So after we get the numbers, we want to get the result. This is going to be perform operation A, B, and up. And we just print the results right here. Let's try it out first. We need to call it as a script. So I'm going to do this in, and I'm going to call the calculate function right here. Let's run this. E0132. Enter the first number, 23, one of the operation plus, and 45. Aha! What it's doing in this case is just concatenating strings, because I forgot to convert the input. The input is going to be a string, but I'm going to convert it into a float here and here. Let's try this again. So 23 plus 45. And we get 68. Now, it returns 68 as a float because I am converting everything into a float to facilitate the option, to facilitate all the operations. But I want to check that if a number is actually an integer, I want to print it as an integer. So what I'm going to do is here, I'm going to check if int result is equal to the actual result, which is a float. So then result is going to be int result. Okay, and then we print it. So if we try this again, 45, 36, oops, forgot the order of things. So 45, 23, again, 45 plus 23. So it's 68. And if I want to work with floats, so if I do 45 divided, and so make it the result to be a float, we actually return a float. And if I do 45 divided by 3, which should return an integer, it prints it as an integer. Okay, that's it for this exercise.
So in the next exercise, we need again to simulate a handheld calculator, but in this case, we need to process input from the Python console representing buttons that are pushed, and then we need to output the contents of the screen after each operation is performed. And we need to have basic arithmetic operations and also a reset clear operation. Okay, what I'm going to do in this case, I'm going to reuse some code I wrote in the previous exercise, the perform operations function, which we're going to reuse, and I'm going to write a calculate function in this case. Before writing the logic, I'm going to print all the allowed operations for this calculator. So allowed operations are, and those are going to be addition, subtraction, multiplication and division. Also, we need to support clearing. So I'm going to add another operation, and I'm just going to be represented with the letter C. So you need to type the letter C to clear. And I would also need an operation to end the whole program. So I'm going to use the letter A for this one. Okay, so this is going to be printed for the user to see. Then we're going to get a number. The first number, I'm going to call it A. And it's just going to be a number. Let me be consistent and use single quotes. Now, what we want to do is, this is going to be the initial input, and then we want to keep the program going after we get the operation and the second input, and then display the result, and then again ask for input. So we want the program to be always running, so I'm going to use a while true loop, which is an infinite loop in this case, unless we break it. And I'm going to get the operation next. It's going to be an input, and then I'm going to say operation. After the operation, I want to get the second number, B, and B is going to be input number again. Okay, and then I want to perform the operation. And I'm going to store it on the number A again. Before I need to convert to float like we did last time. And the operation. And then again, the same we did last time. Check if the number A is an integer so that we can display it as an integer. And then A equals int A, and I want to print A in the end. Okay, what I'm doing in this case, I'm storing it again at A so that we have the initial input, and then we continue running the program, and it will expect the second input and the operation. This will make more sense when we try to run this. So if I try to run 33, okay, we give the first number, we give an operation, and 23. So we print the result, and then we keep it running. So if I give 12 operation, oh, that was my mistake. I should have given an operation. So 45, 63. Again, I need to give an operation. 45 plus 63, 108. And now I can do division 2, and we get 54. So this keeps running, keeps it running, displays what we currently have on the console, and then continue to perform operations on that number. Now we want to add something to clear it and also to end the program. So when we get the input here, first we check if operation is equal to E. If so, I'm going to just break the loop. And if operation is equal to C, which is to clear, I'm going to clear the number by just asking the user to input a new number. So I'm going to get A again from the user. Okay. And then what we want to use continue, which just finishes this iteration of the loop and continues on the next iteration. So this part of the code won't be executed on this iteration, but it will continue, but it will run the next iteration. So we'll start again from the top. Okay, and that is continue. Now we run it again. So we give a number, 36. I want an operation divided by 3, and we get 12. Now I can continue with an operation. 45, we get 57. But now if I want to clear it, I press C. So it's asking me for a number again. 23 divided by 2. I get a float. So now I can continue working on this, or pressing E, I will end the program. Okay, so that's it for this exercise. See you in the next one. In this one, we need to write a Python program that will print this sentence that is commonly written as a punishment, but we will actually make a twist. We should print it 100 times, and we should make 8 different random looking typos on each iteration. Okay, so let's try that. First, I'm going to copy the sentence here, just this one. I'm going to store it in a sentence variable. Oh, okay. Now, what we need to do is we need to first define a function that will handle this. I'm going to call it make typos. It will have a sentence of type string as input. And since we're going to print everything in the console, I'm going to return none. What the easiest way to do this is to actually iterate through a range of 100 numbers, so just to have 100 iterations, and then for each iteration we go through the string and randomly change one of the characters, 8 of the characters. And to change it, we can actually make a random sample of the ASCII codes for the alphabet. What I'm going to do now, I'm going to write a list, ASCII letters, and this is going to contain all the numbers, the ASCII codes for the alphabet, and these are lowercase and uppercase letters. I already looked this up, so the uppercase letters start from 65 up to 90, and to include 90, I'm going to add 91 as the in the range. So I'm going to make this a range and then convert it into a list. And to this list, I'm going, and this is ASCII with double I. I'm going to add then the lowercase letters, which is going to be a range from 97 up to 123 without including 123. Okay, so we have the list of ASCII codes. Now I'm going to make a for loop just to iterate 100 times. And I'm going to convert the sentence into a list of characters, so just a list of single characters. So sentence list. This is because a string is immutable in Python. So if we want to change some character at some index, we cannot do it in a string, but we can do it in a list, and then we can convert the list back into a string by performing a join. This is pretty easy. Just convert this sentence into a list. Now we want the typos to be at random. So I'm going to get some indices for the typos by doing a random dot sample, and for that I'm going to need to import the random module. So if I do random dot sample and I just give it a range, the range is going to be of the length of the sentence, and then I want 8.
So I want a sample of 8 numbers out of the range of the length of the sentence. So this will give me random indices from the sentence, and it will give me 8 of those. And I'm going to iterate through typo indices, and I'm going to change that element with that index in the list into a random. So I'm going to choose. So I'm going to use the CHR to convert the ASCII code into a character, and I'm going to take a random choice from the ASCII letters. Okay. And in the end, I just want to print and join the sentence list back into a string. Okay, let's try this out. I'm going to run this as a script. So as always, if name equals main, I'm going to call the function, make typos with the sentence that we provided. Okay, let's run it. This is going to be P134. I have to activate numlog. Okay. Okay, this is not working. There's something going wrong. Oh, okay. In the join, we need to join the sentence list. So it's just printing the original sentence. I'm going to run it again. Okay. And if you look at it now, you'll see that it's printing pretty much the sentence, but with some 8 random typos. Okay, and that's it for this exercise.
In this exercise, we're dealing with the birthday paradox that says that the probability that 2 people in a room will have the same birthday is more than half, provided the number of people in the room is more than 23. What we need to do is write a program that can test this paradox by a series of experiments on randomly generated birthdays. Okay, now what we're going to do in this case, first I'm going to write a helper function. I'm going to call it random birthday, but random bday short. This is going to produce a date, and we're going to use the date function from the datetime module. So from datetime import date. Now, what the datetime module offers is to convert a date, which is a year, month, and day, into an ordinal number. So it would make it easier to work with a random module to produce a random date. You'll see what I mean when we write some code. So first I'm going to get a random date between 1st of January until 31st of December, which is the last day of the year. And I'm going to use the current year 2023 for that. So I'm going to make a start date. This is going to be date, and I'm going to make it 1st of January, and this is the format year, month, a day. And now I'm going to convert it to an ordinal, which is going to be an integer, and let's call this ordinal start date. Now this is the first day of the year, and I want to get a random day in 2023. So to produce the random day, first I'm going to get a random number between 0 and 364, so random. And for that I'm going to use rand integer, which is from the random module. Not import rand int.
So rand int, you can feed the first number and the second one, and it's going to produce a random number between 0 and 364, including these numbers. Okay, and then to produce the random day, I'm just going to make a date from ordinal. This is a ready to use function. And I'm going to use the original start date plus the random day. Okay, now this is going to produce a random date in 2023, and I'm going to return this. So this is the help function to produce the random birthday. Now I'm going to write a function to perform the test for sample, and we're going to give it a size, which is going to be an integer. This is the number of people in the room, and in the end this should return a boolean true, so it's just going to be true or false if two people have the same birthday for this number of people in the room. Okay, let's make an empty list for the birthdays, and I'm going to iterate through the number of people. So this is and I'm using this symbol because I don't need I am not using I here because I'm not going to use that variable. So this is a common practice in Python. If you're not going to use that variable, you just write something like this. Okay, so what I want in this case is to get the result. And no, I'm going to get the random birthday first. So bday is going to be a random one. And I'm going to check if this one is in the list of random birthdays of the people in the room. If it is, I'm going to break the loop and just return true. So we proved our point. There are two people with the same birthday. If not, just continue adding, so bdays.append the random bday we just generated. Okay, and the function returns false if no two same birthdays are found. Okay, now this is the other function, so I'm going to make this into a program, a standalone script. So I'm going to write, as always, if name equals main, and I'm going to run this experiment for size in a range from 5. I'm going to start at 5 up to 100, but since I want to include 100, I'm going to add 105 as the limit, and the step is 5. So this is going to produce a list of numbers starting from 5, 10, 15, 20, up to 100, like the exercise asks us to. And I'm going to get the result. It's going to be test for sample, and this is going to be for the size. Oh, I forgot to. Okay, this is inside the for loop, and then I'm going to print an f string. So for this size, it is the result. So true or false. Okay, let's run this. So I'm going to run the program. Okay, so we see that for 5 it's false, 10 is false, 15 is false, 20. So yeah, in our case, this is completely random. After 40 is always true. If we run again, we should get something different since it's random. Yeah, so here we see after 25, it's all true. So yeah, pretty much when we're dealing with large numbers, the probability that two people have the same birthdays is more than one in this case. Okay, that's it for this exercise. In this one, we need to write a program that will get a list of words separated by white space and will output how many times each word appears in the list. Now, in this exercise, we don't need to worry about efficiency because we'll learn about this later. Okay, so later I'm going to write an input for the words, but right now let's, as an example, we can write this as a string. So I'm going to make a string called words. It's just going to be, I'm just going to type something that, and I'm going to repeat some words. Okay. Now, what we need to do first, we need to turn this string into a list. So I'm going to call it a word list. And we can do words.split. And to split it, we can use the white space character. So I'm going to make it white space. And let's see what this prints. Word list. I'm going to run this. Yeah, what we want. Now, what we need to do is basically make a frequency dictionary to see how many times a word appears on the list. And in Python, this is relatively easy. We can just do first make a dictionary. Let's call it word frequency. And it's just going to be an empty dictionary. I'm going to iterate through the words. So for word in word list, I'm going to do word freq is for the, so the dictionary is going to have the word as key and as value the number of times it appears on the list. And this one is going to be word frequency dot get. In this case, I'm using dot get notation because if the key doesn't exist, we can actually set a default value equal to 0. And we're going to increase it by 1 because every time a word appears on the list, we need to increase that counter. And now we can just print the word frequency dictionary. And let's see what we get. And this is what we want, the number. So for each key, we have the number of times it appears. So the word hat 3 times, the word cat 2 times, the other two 1 time, and white appears 2 times. Now we can make this into a function. So I'm going to put, I'm going to call this, start right here. Define get word frequency. And this is going to take words, which is going to be a string, and it's going to return a dictionary. And let me put this. Okay, first we convert it into a list, declare an empty dictionary, and then in the end, what we need to do is just return word frequency. Okay, and let's make this into a script. So if name equals main, what we need to do is get an input. So words is going to be input, enter words separated by white space. And after we get that, we call get word frequency for the words. And we just want to, let's call this word frequency and print it. Okay, we don't need this anymore. And let's test this. I'm going to run, and we're going to enter words, cats, and this, and we get the frequency dictionary. And that's it for this exercise. And for the exercises on chapter 1, Python Primer. See you in the next one.